Hello, everyone. Welcome to my presentation about event-based sharding and hyperscaling with Flowable. So I'm Filip Hrisafov. I'm one of the platform architects here at Flowable. And yeah, I'll be taking the last spot in the tech stream today. Just to remind you that all of this will be recorded, so you will be able to listen to it afterwards. And if you have any questions, feel free to put them in the Q&A section of the chat. And then Tess will basically, in the end of my presentation, he is going to present these questions and I will be able to answer them. So let's start with the presentation. So yeah, as I said, we'll be talking about event-based sharding, and before we see, so let's just have a look at just a small agenda. So we'll talk about event-driven architecture, so what they are and why do we need them and things like that. We'll go through the event registry, so basically a solution from us in this world, in the event-driven world, and then we'll touch in hyperscaling and also scaling flow. So event-driven architecture, so what are they used for? So they're used to allow us to decouple services and allow us to basically independently scale and also independently fail our different services that we have running in our environments, right? So it allows us to have something like this, where in the middle section we have the event bus that receives data from event producers, and those event producers push the data to the event bus, and then the data is consumed by event consumers. And all of these things are independent of each other, which means that we can easily scale them differently and plan them accordingly. If we think about event-based architectures, we can also think them a bit in the sense of a process or a case in the Flowable world. And this fits quite naturally, because usually when an event happens, we need to do something, right? So we can think of this that the event is kind of like the command, basically the C in this command query responsibility and segregation pattern, and allows us to capture, basically store the state. So process and cases allow us to store the state that we need to have when an event comes and do a certain thing based on that event, right? Okay, let's go to the Flowable Event Registry. So Flowable Event Registry, we've had it for almost 3 years now. So it was first released in Flowable 6.5.0, which is 22nd of January 2020. And funnily enough, it was actually announced 3 years ago in 2019 on the FlowFest that we had that year. So basically, we've been busy adding things for Flowable ever since then. Right? Before we go into some demos, let's have a look at the architecture that the event registry has. The event registry is segregated in two parts. So at the top part, we can see the events. So basically, this is the structure that the events have. So this is kind of like the schema that the events have, how they're defined, their parameters, and so on. And then in the bottom section, we have our channels. So the channels are the ones which are responsible for consuming the data. So these are the event consumers, basically. And we also have channels which are event producers. So they are split in these two parts that allow us to basically consume and push data to the event stream. Right, and let's have a quick demo of what we can do with events. Let's go to, so we have, I've prepared a small demo where we are going to, I will show you how it looks like. So we have a really small order management process case where we are going to, let's say we would like to order Flowable work, and we can give the email of the customer address, right? So what is happening now, basically we're going to create the case, send an email to the customer, and we will see, for example, here how that looks like. So, oops, make it a bit bigger. So we started the case. Once we start the case, we start this process that actually sends the email, and if we can actually go into this process and see how that one looks like. And you'll see here that we start the process. We have an email which we send to confirm the order, and then we wait for an event to come to receive the order. And this event is actually an email. So this is the email that we've sent, right? And we can now reply to this email and say, okay, yes, I confirm the purchase. I'll show you how all of this is configured in a second. We send the email, right? And now if we go back to our inbox, we will actually, to our case, we can see that we are now on a new step. We are in the validate confirmation. If we open the task, you'll see when was this received, so the timestamp, and we also have the contents which were in the email. So basically, you can already envision that this was already a channel. So this email was a channel, and let's see how this looks like. And what we can actually do with this event channel. So in this example, we have this process where we had this channel here defined, right? So this channel here, it's configured to wait on the system event channel, and we can configure it to listen on different parameters, right? So we say whenever an event comes in with that has the customer email and has this special subject correlation, which I'll explain what is later, we need to trigger this event. And out of that event, we are going to map the parameters which are defined here. So here we can see we map the received date to the confirmation date, we map the content of the email to the confirmation content, and so on. And then we use these parameters which we've defined here, we use them in the case that we have here. And we use them in this form we can see here, where we have just make this bigger, where we use the customer email, we use the order, and we have the confirmation date and the confirmation content for this email. Apart from receiving emails in that manner, we can also use and receive emails based on a boundary. So imagine if we have, let's say, a user task, right? And then we can also have a boundary event, which is the event boundary event. And that event can then be linked to some of our events that we have here, for example. Like we can then open it and then use correlation parameters. Basically, if an event was sent to a particular conversation, we then need to trigger this and then do something with this event. And here we can extract the parameters out of this event. Other use cases that we can do are we can also use send and receive, which is really similar like the one that we had before. But here, apart from the fact that we can configure the inbound event, we can also configure the outbound event. So basically, what do we want to send outside, right? So here we are basically mapping the data that we want to send into the event structure that I mentioned earlier, right? And then we are picking the channel on which we want to send this event, right? And then finally, let's go and have a look at the start event. So we can also start processes. So let's get rid of this. Get rid of this and this. So what we can do is we can have a event registry start event. And here we can again configure an event. And here this looks a bit different, right? So for a start event, we have two things that we can do. Whenever an event comes in, we can start a new process instance and do something with this process instance. What we can also do is we can also say start a new instance, but only when no other instance for this event already exists. So think here, for example, that you might have, let's say, order update event, and your order basically you can receive multiple times multiple updates for the order, but you only want to start a process for the first event, and then you want to wait for this. So you would use this that would match uniquely on all the correlation parameters. So for example, the order ID, and it will only trigger a single process instance. All right, so I think this is enough from the demo, and let's go back to the presentation, and we'll go back again to some of the channels that we have. So let's talk about the channels. So let's talk first. We'll start with the inbound channels. So the inbound channels, we already said that they are consumer channels. So we start first from the event broker side, and these channels actually have two parts. They have the channel adapter part. So this is the configuration that we need to, how do we consume, how do we connect to this broker, how do we connect to Kafka, how do we connect to JMS, and so on, and how do we get the data. The second part is the inbound pipeline. The inbound pipeline is the pipeline which is responsible for transforming the bytes that we receive from the event broker and package them in the Flowable specific structure. So here we have the deserialization. So out of these bytes, we create some structures. So we create JSON or XML. And then out of this, we extract the event key. So this can be, we will see later, either a fixed event or it can be even part of the event itself. We also extract the tenant. So to know in which tenant we need to send the events to. We extract all the payload, so we do special mapping if it needs to be mapped from the JSON structure to the Flowable event structure. And then finally, we do some event transformation, which packages this event structure in something that Flowable understands, and we send it, so we call it kind of like the Flowable event bus, where these different event consumers, for example, which are relevant for BPMN, they will get this event, and they will find all the responsible waiting points, for example, like a received task, an event registry start, a boundary event, and a similar event listener for CMN. They will capture this event and then trigger the BPMN and CMN specific logic for this. So these are some of our supported events, supported channels. We have an open source support for JMS, RabbitMQ, and Kafka. If you have Flowable Orchestrate, you will also have support for AWS SQS. And finally, with Flowable Work, we have support for email channels. So email channels means that you can listen to a mailbox and then capture the emails and use them as input channels for this. So let's have a look at how we can actually configure this and how this looks like in our, so let's go to our channels. And we have here a really simple test channel. We have the inbound channels. We first go through them. So here we have the different implementations. First, we'll go for the Kafka one. And you will see almost all of the inbound channels have two parts. So I have here some advanced settings. They have some, let's say this is richer configuration, which is specific for Kafka, but all of them have this bottom section, the pipeline. So this bottom section, the pipeline, is the inbound pipeline, which is responsible for packaging the bytes that are coming from, in this case, Kafka, and transform them to something that Flowable understands. And all of these sections can actually be customized. So you can use completely a delegated expression with your own pipeline. You can pick the format in which you want to do. So you want to use JSON XML, or if you have a custom format, you can actually use that and provide a delegated expression for that. We have, once we have the serialization, we have the event key detection part. So here we have multiple parts. So one is basically a fixed tab. Whenever this event comes in, it will be, let's say, the customer, right? However, you might have some more specific event structure where on the same topic, you have different event types coming, right? And then you have a certain type, which is mapping those events, right? And for that, you can use these options where you extract the event key out of the JSON field, or you can use some JSON pointers if that's deeply nested and things like that. Once the event key detection is done, we do the event payload extraction. So by default, we map all the JSON fields to the event payload. You can, of course, also always provide your own implementation. Tenant detection is really similar like the event key detection, where either by default there is no tenant ID. So it means that it will use the tenant in which the channel is deployed. Every time you deploy a channel, it's deployed to a specific channel, to a specific tenant. So it will use that tenant. Or if you want, you can use your own fixed tenant or extract it if that's the case for you. And then finally is the Flowable event transformation. So by default, we have our own, but you can always provide your own instance, right? So this would be, I will only say this one. So this will be only for all the channels, this will be the same part, right? So I'm not going to explain this again. And then let's go over the channel adapter part. So this is the part where is how do we actually connect to this broker, right? So for Kafka, we have the subscribe method. So once you're familiar with event brokers, all these namings are specific to every broker. So here we have the subscribe. So we have two types of subscriptions possible for Kafka. We have topics where you can actually, okay, I want to listen to the customer's topic, right? I want to listen to the order. So you define this here. What you can also do is you can also use expressions. So imagine in case you have, for whatever reason, you have the same Kafka broker, but you have different prefixes based on your environment. You can have here, for example, like Kafka prefix, and then this would be then used as a property, will be resolved on the runtime. So that means you can use the same channel, and when you deploy to different environments, you can set this property, and then Flowable will use this property. Another method for Kafka, which would be then relevant for a bit later on, is a topic partition. So this allows us to actually listen to only a specific set of partitions. So we say, okay, we want to listen to the orders topic, right? But we are only interested for this channel to listen on the first 10 partitions, right? And then another channel will listen on the other 10 partitions. The use case for this would be more that you use an expression where we are going to have the orders topic partitions, where you would then be able to define this, and then based on which environment or which instance is running, you configure this differently. This is a really highly specific use case. Most of the time you'll use topics. Then we have some other options which are more advanced, so such as the group ID. And in all of this, you can actually use an expression and resolve this. So the group ID is something unique for Kafka. So how a consumer group is created. So by default, it will be the key of the tenant plus the tenant ID. But you can also, of course, provide your own group. You can also provide the client ID prefix, which will be registered with the Kafka consumer. You can give concurrencies, so which would be how many listeners would you like to have on one instance when you deploy this channel. So not just one, but you might want to have 5, 10, and so on. And then the next three fields, so the partition event field, offset event field, and topic event field, allow you to actually map some specific channel data. So for example, when you receive an event from Kafka, you have access to which partition it was sent to, what is the offset of this event, what is the topic that it was received on, and then allows you to extract this and put it in the event. So here would be, for example, the partition event field, offset event field, and so on. So you can do these things here. And finally, in this advanced section, we have the custom properties. So these custom properties are Kafka consumer group specific. So if you're using Avro, you can here define the schema URL. So this is, I know that this is not really the property, I don't know it by heart, but you can actually provide the location of your schema registry, and you can add other specific properties here, right? Then the next section, which I believe was added in 3.12, is the retry configuration. So Kafka itself doesn't really have the concept of automatic retry. So the consumers are responsible for configuring the retry. So if there is some kind of an error that happens when a message is consumed, the consumers can then create some kind of retry mechanism. So what we've offered, which we are basically building on top of Spring Kafka, is to configure this dynamically. So it allows you to configure retry attempts. So, okay, how many times do we want to retry? So this can be an expression or this can be a number. So you want to retry this 5 times. The dead letter. So if what happens after 5 times, so imagine if this was orders, then we would create a dead letter topic that would then be push this event. And then you can decide what you want to do with this on your own. Have the retry topic suffix. So what do we basically, if we want to add, for example, to every retry topic, some retry, and then we have the different delay types, right? By default, it uses fixed backoff policy, which means that it pushes the topic and then waits for 1 second, and that those other topics will be waited for 1 second to consume this. And then we have all these other options, such as based on the delay types, so the strategies. Do you want to use a single topic for the delay? So it means that if you have 5 retry attempts, you will always push to one topic, or do you want to use multiple topics and then push those? Every retry goes on a different topic. How you want to suffix it, whether you want to use the value of the delay or the index, and then whether you want to automatically create these specific retry topics, which in production you would like to disable, but in your dev environment you like to disable that. So you can also either define those things explicitly or use an expression that allows you to define your own properties, such as Kafka auto create, and then set that value to true or false and things like that. Then you can also, if this is enabled, you can then add the number of partitions and the replication factor, right? And then based on the different delay types, we have some other configurations, such as the actual delay. If you want to have a specific delay, if you want to have an exponential delay, we have basically the initial interval, the max interval, and then the multiplier that you would like to do with the exponential delay. In case you want to use random, you are also possible to use the exponential random delay. And then if in case you want to use a uniform random delay, you can provide the mean and max backoff, and then Spring will perform those mappings. Right, so let's look at the other ones. The other ones are a bit more simple. For JMS, we only need to provide a destination that we want to map to, for example, orders, and then we have some advanced selections, which are also like the first two, message selector and subscription, are basically relevant to your message broker, so allows you to configure your listener to only select certain messages from the broker, not receive all messages. So this syntax would be specific to your broker. The same for the subscription name. And then you can also provide a concurrency, so how many at the same time you want to listen to, so how many listeners you want to implement. Then we have the RabbitMQ, where you provide the queue, same here, the orders queue, for example, and then again, RabbitMQ specific properties, such as the priority that you want to use for the queue, whether it's an exclusive or not, the admin client that should be used. By default, it's used the one which is available in the application environment, but you can, of course, also provide your own, so my custom RabbitMQ admin. So you can use a bean like this to configure to that. And then we have the act node and the executor, which you can also configure. So all of this is available in open source. And now the next parts are some things which are not available in open source, but they're available when you have Flowable Orchestrate or Flowable Work. So AWS SQS, so here we provide the queue URL, so the one which you have already available in your Amazon console. So you would provide this here. And then in the advanced sections, because this uses the AWS SDK, so it uses actually REST to fetch the data. So we have the number of messages that you want to fetch in one go. So by default, it uses whatever is provided by AWS SDK, but you can provide your own numbers. You can, of course, as always, use an expression. We have the visibility timeout. So once you fetch a message, how long should this message be hidden from the other consumers? Which means that how long should AWS wait for you to acknowledge that you are finished with this message and delete this message before it's made available to the other ones, in case your node fails. Then we have the wait time. So how long should we wait for receiving these messages, because something can happen, right? And finally, but not the least, we have the message deletion policy, which means that what happens once you consume the message, right? So by default, we use the no redrive policy. So which means that we check your queue. So we check your queue to see what to do on failure, right? So redrive in AWS means kind of like retry, right? So if you use this policy, or if you use the no on success policy, whenever there is a success, you're going to delete the message. Then when you use no redrive, if there is no redrive, we are going to delete the message when there is a failure, right? However, if there is no if there is a redrive configured policy on your queue in AWS, we are going to basically not do anything and leave it to AWS to retry this message, so some other broker to retry or do something else. And we have on success. On success means we always leave it. We don't delete if there is a failure. And then always means we always delete, even if there is a failure, we always delete the message. And finally, our final channel is our mail channel. So this you can already see looks a bit different. So we don't have the pipeline part because emails have a defined structure. So we extract this. We don't need to tell us how to extract this. We already know how to extract and map this to the event, right? But what you configure is how we connect to this channel. So here we provide the IMAP URL that we want to listen to. We have the event key, which is in case you don't want to use the one from Flowable, if you want to use your own key. And here we have the advanced settings, which are around the subject correlation pattern and some other things. So here the subject correlation pattern is, you saw how the email looked like, right? So the email looked like it had something capital letters dash, and then it has something afterwards, right? So this was actually the correlation parameter. So it was this Flowable work here. So the way that this looks like, you actually configure something like this, right? And we are going to say, okay, whatever is in these brackets, is our correlation parameter, and everything else is just matching, right? So this is how you define these things. And then we have some other things. What should happen once a message is read, if in case we need to delete it or not, right? Whether we should mark messages as read, what is the polling rate? By default, I think it polls every minute, but you can actually say, okay, I want to poll every second or every 10 seconds and things like that. How many messages you want to fetch when you poll? And then we have supports idle. So not all. So in this example, so the ones that you're using, so this round cube test mailbox doesn't support idle, but Outlook does support this, which means that the polling rate will not be used. But whenever a new message comes in, you will actually get kind of like a push notification for this. Then we have things such as the user flags, which means that once you read the message, you want to somehow flag it and have some specific flag. And then we have the username and password, basically, how do we communicate? How do we connect to these mailboxes? And of course, you can always provide your own implementation for the authentication and add custom properties. So this would be in case something specific around IMAP and you want to do something there, you can use these properties to expose this to your to the channel listener. Right, so that was around inbound channels. And let's now go to outbound channels. So now outbound channels are actually the reverse. So those are the event producers. So here would be a send event from the Flowable side of things, which is going to give this data to the outbound pipeline, which is responsible for transforming this Flowable structure, doing the event transformation, and then performing the serialization, basically the bytes that the broker understands. And then once this is done, this is given to a channel adapter. But now this channel adapter is the producer. So this channel adapter is how do I send to Kafka? How do I send to JMS, right? And this is the one which will send it to the broker. And for outbound channels, we have the following ones. So we have JMS, RabbitMQ, and Kafka. Again, only supported for open source. Then we have AWS SQS, which is available in Flowable Orchestrate and it's already available there. And since the next release, Flowable 3.13 with the Orchestrate product, we will support AWS SNS. So we only support AWS SNS as an outbound channel, and then you configure SNS how you want to distribute these messages. So let's see how they look like. So the outbound channels are way simpler than the inbound channels. We have different implementations, right? And then we have here also two parts. We have the part which is about the channel adapter, but we also have the part around the pipeline. So the pipeline is nothing more than, okay, what are the bytes? So is it JSON, is it XML? So this is what we support. And of course, as always, you can provide your own custom delegate expression. And then in the channel adapter, so these are some more advanced things that you can do. First, the topic, right? So we want to send to order update in case you're updating orders. In case you have a fixed key, you can use this. Most likely you don't have that. And then what we also have, we have partitions. So in case you want to send to a specific topic and partition, you can use this. So you can use an event field. So whatever it was defined into the event field, event partition field, right? So whatever is in this field from the event, we will use this to push it to this event. Then we have round robin, where you define, okay, I want to only do the first 5, I want to do the number 8, and then I want to do between 10 and 15, right? So you can configure this, and then Flowable will do it in a round robin. So the first event will go to 0, and then the next one to 1, and you get the idea. And finally, you can use your own expression to perform this. And you can also use the default one, right? So you can use a delegate expression, or you can use some of these things. And of course, the round robin, I forgot to mention, you can use an expression, which then comes from a property. So this would then allow you to configure these things based on different instances. So first instance stands from 0 to 9, then the next instance from 10 to 19, and so on. JMS is really simple. You only need to provide the destination for JMS. RabbitMQ, similar like JMS, you provide the routing key and the exchange as an advanced property. Then we have AWS SQS, basically the queue URL which you have in your AWS console. And then AWS SNS, it's a bit more, well, not complicated, but it has a bit more configuration parameter options. So you have the queue URL, the ARN, as AWS calls it, so you can provide that. And then you can provide the subject provider, so which is something specific for AWS. By default, you can use an expression or a string, right? But you can also use an event field, so to extract this subject from the message, or you can use a delegate expression, which will provide you this value, right? And then we have the first in, first out, depending on the type of the SNS queue that you have. So you can provide the group ID, which is a fixed value, or you want to use an expression. And again, you can extract it from a field or a delegate expression. And the same thing for the deduplication, basically how do you make sure that the message is unique, right? All right, so that was all with our channels. And let's now go into scaling Flowable before we go into hyperscaling. So actually, there was a question earlier today in the session of tasks. I have it written here. So how do you scale Flowable work horizontally? And the sessions would make this impossible, or it make it really hard to scale this, right? So the one I'm happy to say is that Flowable is actually stateless, so it doesn't really need sessions, right? So this means that you can actually, we don't really have any limits on the horizontal scaling that you can do with Flowable, right? Of course, when you scale Flowable, you also have a database, which is always the bottleneck, right? So that for us, we've seen from all our benchmarks, if you push it a lot, it's at some point it stops, right? You can always scale it, right? You can add more CPU, more memory, more disk speed. So that's how that's one of the first things that how you would scale Flowable, right? However, sometimes the scaling the database and for some specific use cases, it's complex. So that's why we've had this, like recently for some of our customers, we've tried to look at some other approaches, and we have an approach where you can actually use multiple databases and multiple Flowables. So basically a database and Flowable is one stack, and you can scale this horizontally without problems, and we'll explain how this can be done. But before you do such things, it's always worth taking some performance considerations and analyzing your processes, right? So it's always really good if you have a lot of data, if you need to have high performance, to think about the data that you're storing. So Flowable has this concept of runtime data, where everything which is runtime is stored, and the historic data which contains all the data which is done. And it also contains the runtime data. So the runtime data is a subset of the historic data. So you can actually tweak this a lot. So you can configure the history level. So which means that you don't want to store any historic data, or you only want to store instance level historic data. So only processes, cases, right? You want to store tasks, so processes, cases, and tasks. And then you can go further audit and so on, right? You can reduce the amount of variables. So maybe you want to use more transient variables, or you should use primitive or small JSON variables to decrease the load that is being done on the database when we persist things there. And then, which is also really important, is consider parallel communication, especially when you do external service calls and use parallel execution for that. Because imagine that if you have two HTTP calls, which are sequential, and each HTTP call takes 5 seconds, Flowable cannot finish those two HTTP calls faster than 10 seconds because it needs to wait 5 seconds for the one to complete, and then it goes on the next one, 5 seconds, and then it can complete. However, if you use parallel execution, we've done some improvements where actually this parallel execution for these HTTP calls would actually be done in parallel. So we will do a call for the first one and have a wait for it to come back, but also in the same time we'll do another call for the second one and wait for that one to come back, and then it will actually take 5 seconds instead of 10 seconds. And just so you can see what it means changing the history level. So here we can see on the left-hand side, we have a single send and receive. So basically a start, we send the event to Kafka, we wait for event from Kafka to come back, and then we finish. On the left-hand side, we have the default history level, which is audit. And here we can see we have around 17,500 completed process instances, right? And then on the right-hand side, nothing changed. So the only thing which we change is the amount of data which we are storing in the database. So we picked the non-history level. So nothing was going in the historic table. So here we can see already a 30% improvement just by setting a single flag. Of course, you need to take into consideration your data, but here we see that we have around 22,000 completely processed instances. So this is quite a big improvement that you can gain by thinking around your processes, thinking around your data, what you need, what you don't need, and things like that. All right, so let's go now into hyperscaling. So as I mentioned earlier, so hyperscaling is something not as a last resort, but it's a tool in your toolbox that you can use at certain points, right? So we suggest using this when you can no longer scale the database, or scaling your database becomes too complex. And we'll explain why this is the only use case. So the reasons for this are, you have to think about user action. So hyperscaling means you have multiple Flowable databases and multiple Flowable instances communicating with those databases. So you no longer have a single place, a single instance that you can go to and get all the data that you need to do, right? Need to complete user tasks and things like this. So there are ways, of course, that's why there's an asterisk, how you can achieve this by using a dedicated instance and sending the data there, but this is, of course, complex. And then this hyperscaling works mostly in the event streaming world, and mostly when you have things like Kafka, for example, that allow you to do this hyperscaling and splitting of the data. And it's meant mostly for straight-through processes that don't really need user action, which is a bit linked to above. And this is how an architecture looks like. So here we can see on the left side, we have the 3 Azure instances, which each instance communicates with a single Flowable work instance, and those 2 create a Flowable stack, as we call it. And then we had a Kafka VM running, which was then a third-party Kafka listener, which was responding to our listened events. You'll see why. And we had an Elasticsearch VM to basically only capture some metrics. And this is a process that we've used to perform this benchmark. So you can see here we have 5 events. So we receive an event, we then send this event outside, we wait for an event to come back. Once the payment comes in, we then send an event for the order fraud, then we wait for the order, and so on. So this looks somehow like this when it communicates. So you can see how it flows with the broker. And just so you see the problems, we have one event when it's received on one instance. So we have the order 1 received, right? It starts a process instance, and then it sends some payment, right? But so this means that whenever now a new order comes in, it has to arrive. Well, not a new order. Whenever a payment update comes for this order 1, it has to come on the instance on the stack that contains this data, otherwise it will be ignored, right? So that's why we had to configure those things which I mentioned earlier, that we had one stack only receiving data from the first 10 partitions and sending data to only 10 partitions, and then the other stack was only receiving on the next 10 partitions and so on. So this is how it looks like order 1 and order 2. And if we simplify this a bit from the events flow perspective, we can see we have the two different stacks which are communicating with the event broker, and then different orders are going on the different stacks. The Kafka topic setup that we had in this one, so we had 12 topics actually. Each one had 200 partitions with one replica, and we pre-filled the first one with 12 million events, around 60,000 events per partition. Flow of work was configured in the following. So we had 20 Kafka listeners. So this means that we were consuming, when one stack was consuming on 20 partitions in the same time. So that's how Kafka allows us to basically parallelize things, amount of partitions. And we had 50 partitions, so we could go up to 50 Kafka listeners. Once you go above that number, the other listeners are no longer doing anything. They're waiting for a partition to become free so that they can listen to. We've disabled Elasticsearch to reduce, again, the load on the database, because that's how we do the indexing. We've enabled the metrics so that we can create the graphs, which you will see. And then we've added some other specific Kafka things, such as the number of consumers, so number of polling records. So in one bucket, we would get 50, and then we would continue. We would do those things in batch. And this is what we got. So basically, on this graph, you can see the completed process instances. So this is, but remember, these are the completed process instances that I showed earlier. So this means we received 6 events before we received 6, and we sent out 5 events before we completed this process. So on one instance, we got around 10,000 completed processes per minute per stack, right? Global instance and a database. And this accounts to around 50,000 events if we have 5 events being received, right? And then if you scale this, you can then just add the amount of instances. So if we have 10,000 completed instances, we have, once we add three of those stacks, we can have 30,000, right? If you had another one, a 4th stack, it would be 40,000, right? So you can imagine that how this can then scale up to until basically Kafka can keep up with the load that we are sending to it, right? And this amounted to 1.8 million completed process instances per hour, basically. So to recap, Flowable does scale horizontally. We showed earlier that you can easily scale it. You should always think about your data. So think about a history level, how you can reduce it, how you can reduce the amount of data, tweak the history level, right? And then look into hyperscaling when you can no longer scale your database or scaling becomes too expensive, and think about what do you need to do when you have a user action, and make sure that your other, let's say, if other event producers and consumers are aware about such hyperscaling, that things have to be sent on specific partitions for Kafka. So yeah, thank you very much. And let's see if you had some questions. I think Tess will now be able to let me know if we had some questions and if I can answer them.
Yeah, cool. Thanks a lot, Philip. So let's go a bit into the questions. So if there are any more questions, please use the box at the bottom of your page. So our first question, which JMS brokers are you supporting? For example, do you support AMQ? So I would think that's ActiveMQ, using AMP SSL protocol.
Yeah, so basically we don't really care about the broker which you're using, because we are doing this using Spring Kafka. Sorry, not Spring Kafka, Spring JMS. I've been working a lot with Kafka lately. So Spring JMS, and we use the JMS abstraction. So if your instance is configured with a broker that can implement JMS, then we do support it. So we have tests for ActiveMQ because that comes out of the box with Spring Boot, and we also have QA and we have tests for IBM MQ, and we also have some auto configuration support for communicating with IBM MQ. So yeah, I hope this answers the question.
Cool, thank you. So another question, are outbound channels all about fire and forget? Or is there a way to correlate outbound, inbound channels for synchronous request response messages?
So yeah, so outbound channels are more for, well, it's more for fire and forget. Yeah, so basically you send the event and then you don't really care what comes back, but usually you send the event to event broker, right? If you need to use some kind of like a correlation pattern, there are ways. So basically when you send the event, you send some identifiers in the event, right? For example, like an order ID, and then you can have a receive event which listens for this specific event to come back, right? If you need to use asynchronous, more like synchronous things, I would suggest using HTTP tasks basically for this, because yeah, it can easily react and knows what happens when the connection goes down or when Flowable is down and things like that. Yeah.
Cool. Yeah, I think there are a couple of questions a bit related to each other about the scaling demo that you were showing, where basically there were multiple Flowable instances, but also multiple databases, right?
Yeah.
And a bit of combination of two questions is, do those databases need to be kept in sync? And do they need to have the same models? Yeah, so maybe you can answer that a bit combined.
Yeah, so that's actually a really good question. So actually the whole idea of this is that we don't really need, you don't need, they're completely independent, right? So those two stacks have their own databases and they have their own schemas. They don't need to be kept in sync because the data is actually different. So some of the events are received by stack 1 and some are received by stack 2. So automatically the data is different, right? And then the second part, which is, do you need to have the same models? So that would be yes and no. So like the model which you're, let's say you have the process that you need to execute, right? So, and that process receives these events and then does something, right? So this of course has to be available, because if it's not available, then the channel will not be listening to anything, and then you will not be able to execute. The events will be just ignored. So in a way, yeah, you need to have them, but however, you can have, let's say, other events and other models which are different between the instances deployed, because they're completely independent of each other. So yeah,
one question from Fleming. So hi, Fleming. So he's asking, I see that you can configure one RabbitMQ connection. So yeah, you can still have multiple queues, of course, and topics, but it's coming from one RabbitMQ source, basically. So let's say you would have multiple RabbitMQ sources, or maybe different JMS brokers where you want to connect to. Would that be possible?
Yeah, so with RabbitMQ, that's the RabbitMQ admin part that I mentioned, that how we actually communicate. So there, you would be able to provide your own instance. So let's say in your own application, you can expose multiple RabbitMQ admin beans in the Spring context. And then you would be able then to pick which one you want to use. For JMS, there is only one which is currently possible. However, that's actually it's a really good use case. We've heard it before, and it's something worth investigating, that you can actually provide even the broker configuration parameters in the channel adapter, so that we actually only connect to that specific broker, and then you have channels communicating with different brokers. So yeah.
Good. Yeah, I think we reached the end of the session. So thanks a lot, Philip, for the presentation. So now it's the end of this tech stream, but the business stream is still continuing. So there are still presentations there. So if you are looking for more content, definitely switch to that stream. And yeah, we want to thank everyone for watching the streams, and the recordings will be made available for you for later viewing. Yeah, so thanks a lot, and we will keep in touch.
Thank you from my side as well. Yeah, hope you enjoyed our session.
Great, thank you.
Bye.